Spotify is a streaming music company with more than 50 million listeners. Whenever a user listens to a song, Spotify records that event and uses it as input to learn more about the user's preferences. Listening to a song is one type of event. There are hundreds of other types of events. Opening the Spotify app, skipping a song, sharing a playlist with a friend. All of these are events that provide valuable insights to Spotify. And these are not the only types of events that Spotify cares about. There are also events that occur at the infrastructure level. For example, a logging server that runs out of disk space. There are events that are relevant to all the users on Spotify. For example, a new album release from Taylor Swift. An event is an object that needs to be registered within a system. Since there are so many events on a platform like Spotify, delivering and processing them reliably requires significant investment. Modern internet companies are built by connecting cloud services, databases, and internal tools together. These different systems might respond to different events in different ways. Each system subscribes to the type of events that it wants to hear. Since there are so many events coming in, and they might be received at uneven bursts, a modern cloud architecture has a scalable queuing system built to buffer events. To put an event on the queue, the event publisher publishes that event to the queue. The event is then received by each subscriber. That's why queuing is often known as Pubsub or publish subscribe. Igor Maravic is an engineer with Spotify. In this episode, he explains why Pubsub is a key element of Spotify's infrastructure. And he describes the migration that Spotify has made from Apache Kafka to Google Cloud Pubsub. If you like this episode, we've done so many other shows about cloud infrastructure, and you can find those episodes easily by checking out the Software Engineering Daily app for iOS. This is the easiest way to browse our old episodes and easily discover new topics that might interest you. You can upvote the episodes you like, and you can get recommendations based on your listening history. With 600 episodes, it's hard to find the episodes that appeal to you, and we hope that the app helps with that. If you're interested in contributing to the Software Engineering Daily app ecosystem, we're working on an Android app, we're working on a web front end, and we're working on a back-end recommendation system. So all of these software projects could use your help if you're interested. You can go to github.com/softwareengineeringdaily and check them out. With that, let's get to this episode. To build the kinds of things developers want to build today, they need better tools, super tools, like a database that'll grow as your business grows and is easy to manage. That's why Amazon Web Services built Amazon Aurora, a relational database engine that's compatible with MySQL or PostgreSQL, and provides up to 5 times the performance of standard MySQL on the same hardware. Amazon Aurora from AWS can scale up to millions of transactions per minute, automatically grow your storage up to 64 terabytes if need be, and replicate 6 copies of your data to 3 different availability zones. Amazon Aurora tolerates failures and even automatically fixes them and continually backs up your data to Amazon S3. And Amazon RDS fully manages it all, so you don't have to. If you're already using Amazon RDS for MySQL, you can migrate to Amazon Aurora with just a few clicks. So what you're getting here is up to 5 times better performance than MySQL with the security, availability, and reliability of a commercial database, all at 1/10 of the cost. No upfront charges, no commitments, and you only pay for what you use. Check out aurora.aws and start imagining what you can build with Amazon Aurora from AWS. That's aurora.aws, aurora.aws. Igor Maravic works at Spotify as an engineer. Igor, welcome to Software Engineering Daily.
Thank you, Jeff.
I'm looking forward to talking to you about event delivery today. This is a fundamental component of Spotify's data engineering infrastructure. And I want to start off at perhaps a different place than event delivery and just talk about Pubsub systems, because this is sort of a prerequisite for getting into the meat of our discussion. And Pubsub is a pattern that is useful in software architecture for reasons other than event delivery. So let's just start there. Describe why an organization, particularly a large organization like Spotify, would need a Pubsub system.
So I think there are a few different use cases. So one of the use cases that we had in the event delivery system is that we wanted to completely separate the producing side and the consuming side. So in case of the issues with actually producing, we would still be able to consume data and actually deliver it. And then also like the other way around, in case we're having issues with the consuming side, we still want to keep on publishing the messages, so they would be buffered up somewhere in the Pubsub system, so we could actually consume them once the system is up and running on the other side.
Well, I probably should have asked this at first, but why don't you just explain to the audience who is unfamiliar with the term Pubsub what a Pubsub system is?
So it is actually a system where you would, publish the messages. They would be buffered somewhere. If you're using a cloud provider, then somewhere in the cloud. And then on the other side, you would just, consume them once you have the subscribers. And the idea is that you would probably have one publisher and then multiple subscribers, which would actually start consuming from the stream. So, for example, in our case, even if we do have multiple publishers, because every service from which we collect the data is publishing data, we also have multiple consumers, but also different clusters of consumers. So one of the clusters, for example, that we're using is the one that is delivering data and which is getting persisted to a persistent storage, and the other type of users are the real-time users, which every consume the same stream, and they would essentially get the same data, but they would use it to produce a different result.
Mm-hmm. And I remember the Pubsub pattern being a little confusing to me when I started software engineering, and I think as an example in Spotify might be like if a person, let's say a user plays a song, they just play a specific song or they play a playlist on Spotify, that event, at Spotify, multiple teams are going to want to know that event occurred. So you've got, first of all, you've got just like the infrastructure side where, the event occurs and maybe you need to serve up a playlist or perhaps update a playlist or just update the number of plays that a playlist has received. And then you also want that event to propagate to the data science team, the data engineering team, so they have it saved and can do all kinds of analysis in the future. But more abstractly, you just want a system where multiple people can have access to this single data source. That is kind of the root abstraction of the Pubsub system. So what are some of the systems and the services that are built using different Pubsub systems at Spotify? Why is this a core abstraction to a large organization like Spotify?
So I think that's an interesting question, but before I actually give you the answer, I need to tell you the Pubsub system, which we're using to deliver data, is a completely different compared to the Pubsub system, which is actually used for distributing events inside of the services in Spotify that you just talked about. So the difference is because basically these two Pubsub systems have a kind of different requirements. So the one Pubsub system that needs to react to every user and then also kind of probably publish some of the updates to many clients needs to actually have a lot of topics in it, and it needs to handle it with a low latency. The one Pubsub system that we're using for the event delivery has a bit of different use case in the sense that we don't have as many topics and we're not as sensitive for the latency. So the system which is used for the services is being used, as you said, for the playlist team or by the playlist systems, but it's also being used for the connect. So this is when you actually play music from your phone, that you're actually able to control your speaker, that you're able to control your Chromecast. I think like, what's the name? Google Home or like Amazon Alexa and stuff like that. So because of that, it is one of the core components of how we do stuff, or like what we provide to the users.
Mm-hmm. Okay. Well, now that we've given a little bit of an intro for Pubsub, let's talk about event delivery. What is event delivery? What does that term mean to you?
Because I've been working on this for the past 2 years, it means quite a lot to me. So essentially, what event delivery means is that we need to know when the user plays a song, when the user creates a playlist, saves a playlist, and I don't know, many different reasons, and we need to collect them and put them in a place where it would be convenient for other teams to do data processing on them, so we could actually learn more about our users, and we would be able to provide good music recommendations and stuff like that. But it's also, one important thing is basically, based on all of these streams, we're also generating royalties, which essentially are generating revenue for all the artists that upload music to Spotify.
Could you give some examples of specific events in the event delivery system?
Well, I mean, definitely playing a song is one event. Yeah, I mean, that would be the basic event for Spotify. But it's also like user clicks, ad clicks, and that kind of stuff.
Got it. Okay. And we've got some different kinds of services that can generate events. So there might be an external API request. So if you're on an iPhone and you're using Spotify, then that's going to make an API request to some service at Spotify. That's going to generate an event. There's also internal services like some sort of processing event, or maybe you're checking some music for DRM that could generate events from internal systems. How does the event consumption process or the event generation process, how does that differ between internal services and services that are using an external API?
I would say they're actually pretty the same. I mean, the main thing is like something have happened that you want to track later on, and then you just generate the event. And then wherever the event gets generated, the interesting part, it actually always talks to the API of our event delivery system. We also have a service, and that's pretty much it. And from our perspective as event delivery team, we don't distinguish them as much.
Okay. Let's bring these two concepts together, the Pubsub system and the event delivery idea. So an event gets created in any context across Spotify's footprint, whether it's on a user's app or on Spotify's internal infrastructure, and that event gets published somehow, and then somebody is going to consume that event elsewhere. Give us an overview for the abstraction of an event and how it gets conveyed from the publisher to the subscriber.
So the first step, as I already said, is that it actually needs to reach one of the microservices, which is, you could call it a gateway for the event delivery system. We actually then take and translate the event from a, tab-separated format or a JSON format, and we convert it to the Avro bytes. From them, we just publish it to a Pubsub system, and that's pretty much where the publishing part finishes. Other part is like every of those events are now living in one of the Pubsub streams. Each event type gets its own topic. And then on the other side, we have consumers which are consuming that event and delivering them to a temporary location. So this might be a bit more technical, but here is the interesting part. All the events which are being delivered to a storage in Spotify need to be bucketed into hourly buckets. So we also have a system which is tracking how far did we get with the hour and could this hour be complete. Once it detects by some heuristic that the hour can be complete, we have a MapReduce job which takes the events from the intermediate storage belonging to an hour, deduplicates them, and then finally writes them to their final destination. And that's pretty much the end of the process. And then we could actually have a lot of consumers starting to consume the data, processing it, and of course producing more data and so on.
Amazon Redshift powers the analytics of your business, and Intermix.io powers the analytics of your Redshift. Your dashboards are loading slowly, your queries are getting stuck, your business intelligence tools are choking on data. The problem could be with how you are managing your Redshift cluster. Intermix.io gives you the tools that you need to analyze your Amazon Redshift performance and improve the tool chain of everyone downstream from your data warehouse. The team at Intermix has seen so many Redshift clusters, they are confident that they can solve whatever performance issues you are having. Go to intermix.io/sedaily to get a 30-day free trial of Intermix. Intermix.io gives you performance analytics for Amazon Redshift. Intermix collects all your Redshift logs and makes it easy to figure out what's wrong so that you can take action, all in a nice, intuitive dashboard. The alternative is doing that yourself, running a bunch of scripts to get your diagnostic data and then figuring out how to visualize and manage it. What a nightmare and a waste of time. Intermix is used by Postmates, Typeform, Udemy, and other data teams who need insights into their Redshift cluster. Go to intermix.io/sedaily to try out your free 30-day trial of Intermix and get your Redshift cluster under better analytics. Thanks to Intermix for being a new sponsor of Software Engineering Daily. The reason I reached out to you is because you wrote this 3-part series on a migration of the event delivery system. So originally, you were using this Kafka, you were using a system using Kafka, and it was pretty complicated, and over time you audited some other Pubsub options, and you came to the conclusion that Google Pubsub was the right way to go. So I'd like to talk about evaluating your own, well, first of all, I guess, constructing your first event delivery system that existed at Spotify when Spotify was growing and just building out its infrastructure, the V1 infrastructure. And then we'll talk about the shortcomings of that event delivery system, and then we'll get into the migration to Google Pubsub and why Google Pubsub was a useful system. So let's talk about the historical infrastructure. Why don't you give an overview of what Spotify's infrastructure looked like at the point of creation of the first event delivery system? Like, I guess I'm not sure about the timeline. When did you first build that event delivery system, and what did Spotify's infrastructure and kind of the requirements for that first event delivery system look like?
So I can actually give you, as far as I know. So I've been in Spotify for, well, right now, I think it's almost exactly 4 years. So the first event delivery system actually predates me, and I'm not really sure how everything looked before that. So when I joined, this was a part that Spotify didn't have a monolith. We had a lot of microservices, and everything was written in Python. So important thing was like all the events first would actually be written to syslog, and then somehow they would need to be delivered to Hadoop. So the first event delivery system that Spotify ever had was just SCP, which would actually copy the hourly log files into a Hadoop so people could use them. So I think it was at some point pretty obvious that this doesn't really scale. problem was that the SCP was having some really nasty like crashes, and it would be really hard to understand, did it work, did the file was actually copied correctly or not, was there any corruption in between, and so on and so on. And this is how the team, then the event delivery team, decided to actually build the second version, which was based on Kafka. So this second version is the one that I described in my blog post, and this is the one from which we actually started migrating from. I think the biggest drawback with this version is that we were using Kafka 0.7, which didn't have the persistence like Kafka 0.8. So essentially, we tried to use the system as a PubSub system, but we were not doing that because we were not keeping any state in between. So we were depending on the data being delivered to HDFS first, or Hadoop file system first, and then sending the acknowledgement back to the beginning of the pipeline so we would know that something was transferred.
So was the earlier version of Kafka, I guess the 0.7 version, was that more of a less reliable persistence model, or you could not set as flexible as of a retention policy?
No, I think it was actually not having this persistence. So it was pretty much like a run-through buffer, because the brokers which you had in the cluster, they were not in the same cluster, so the data they actually had was actually always stored only on one broker. So if one broker dies, you lose that data completely, which kind of made it not safe to actually store data on the broker cluster, and that's why you actually need to first deliver it somewhere where we know we're not going to lose it before saying it's delivered or not.
I see. And this is kind of getting off topic, but what did Kafka do to ensure that messages didn't get lost in those days?
So here is the trick. It didn't do anything. So when we actually, I think we were halfway in the migration, and we actually looked at the system, and we actually figured out we didn't need to use Kafka at all. We could just send an HTTP request to some server somewhere, which would actually write it to a file and send an acknowledgement when the event was written to a file. So there was a lot of complication and not gain. We didn't get any gain. It felt more like the Kafka at that days, like early days, was really cool technology that we should use, and I guess that's what they did.
Interesting. It almost sounds like it was more of an aspirational technology in those days, where people were saying, okay, we know it would be useful to build a really powerful open source PubSub replicated abstraction, but then maybe it got released to the open source community before it had kind of the necessary details to be totally bulletproof for a system like Spotify for this particular application.
Yeah, but I think it's still a good strategy. I mean, you should release early and often.
Of
and
course.
I think they got a lot of traction. I mean, I think they did a good job on that part. So when the second system was built on top of Kafka 0.7, they immediately wanted to migrate to Kafka 0.8. Because with the Kafka 0.8, you actually got a persistence in the cluster. So if you have three brokers, they share data somehow by some, I think I forgot that one, but it was like some custom algorithm that Kafka implemented. So if one broker dies, it should actually keep the data and you should not lose the data.
Mm-hmm. Got it. Okay. Well, getting back to this architecture, getting back away from the dissection of Kafka itself, maybe you could tell a bit about. I mean, so you don't need to describe the whole architectural diagram. I looked at it, and it was pretty complicated. The first one was pretty complicated, but maybe you could just talk a little bit about the operational burdens of running that first event delivery system, and also I guess we've kind of glossed over this, but the goals that it was trying to accomplish. I mean, in that context, I think at that time you were doing things like running some Hadoop jobs, and I don't know what else you wanted the event delivery system to be able to interface with. But just talk about operationally what your goals were with the event delivery system and what the operational burdens were.
So I think the main goal was to deliver the data. Well, that was pretty much it. Operational burden was pretty big because if you have like many data centers, for example, we had a lot of networking problems between them. So because Kafka didn't store any data on it, and we actually depended on every event first going from one data center, for example in US, to the Europe data center, be delivered to Hadoop, and then send the acknowledgement back. So the problem is, like, if you have any problems with the network link, if you have a high latency, then the whole system is really slow and unreliable to work with, and you would sometimes get a really nasty loop of failures. So for example, if it's slow but your timeout is not good enough, or like your buffer is not good enough, like everything explodes. We've also had some fun issues with the actual disks. So I think 2 years ago, we hit a nasty BIOS bug, which actually caused CPU to think it is overheating. So when the BIOS would actually detect a CPU as overheating, it would completely dial down its own, like a pace with how fast the CPU works. And then you would actually get a machine which is kind of working, but it's almost dead. So, and then the interesting part was that if one machine from the cluster is not working with the full speed, all of the other machines are also, for some reason, really, really slow. I think to actually discover that incident, it took us like almost 3 days of like no sleeping and like trying to make everything work. So it was not that fun. We also had a lot of problems with the way we were delivering data. So back then, we did not want to accept any late data at all. So all the data would need to be delivered, and we would block until we ensure that everything is delivered. But then again, we have around, I think, at that point, we had around 1,500 servers from which we were delivering data. And then, like, servers would die at least weekly. And then that would also entail that we need to wake up in the middle of the night, go and inspect the server, and we say, oh, well, the server is dead. Now we, need to manually say, well, let's process the data and let's continue working on. I guess, I can't remember now out of my head, but there were quite a few issues with this system.
So were there issues with maybe a lack of resiliency to the failure of any single component? Like, it sounds like if one part of it failed, then you could have some catastrophic outcomes across the entire system.
Yeah, so yeah, exactly. I think it was more like design issues which were baked into the system more than like other component problem. Like, Kafka was working okay for what it actually needed to do.
So as you were deciding to migrate to a new system, what was going through your head? What was the motivation to migrate?
Definitely motivation. So at some point we had a doomsday clock. We did some calculations about how much capacity can we push through the pipeline. And at some point we figured out, well, if we actually grow as fast as we were growing back then, we're not going to be able to deliver the data in the SLA that we've set before. So I think that was the main motivation. Other motivation was also, I guess, kind of more modernizing the system and changing a design a bit. So being on call would not be a punishment. Basically, we would be able to have like nice nights or even go out when we're on call without us being like paged that we need to manually do stuff.
What were the requirements that you had for the new system that you were going to migrate to?
So number one requirement, it needed to deliver data with the SLA, which is as good as the previous system or lower. So currently our SLA that all the data needs to be delivered in under 6 hours. The other requirement was that we should not lose any data at all. And this is because we're delivering data from which we actually generate the royalty payouts. And we also had a requirement that we need to prove that we're not losing any data.
Mm-hmm. You need to prove it.
Yes.
How do you prove that you're not losing data?
So how much data gets in, that's how much data gets out on the other side.
Oh, okay. So you're saying like in the intermediary. What exactly are we talking about when entering X, you need to not lose data? Are you talking about the queuing system?
Yeah, it's a queuing system, but it's more like, I mean, the overall thing. If you're actually sending acknowledgements before you, for example, publish it, you're losing data. You're probably going to lose the data because you might drop it before you publish it. Or like once it actually enters the Pubsub system, you also need to be sure that it's not losing data anywhere. But also the way you're consuming data, the way you're deduplicating data, you also need to ensure that you don't have any bugs which are actually going to drop randomly your events.
So you're referring to the acknowledgement of receiving data. So if you have in distributed systems, oftentimes when you send a message to a recipient, the recipient needs to acknowledge the receipt of that message, because otherwise the message might get lost in the ether and neither side, and then both of the sides are confused because, if user A if Alice sends a message to Bob and Alice does not get an ACK, then Alice doesn't know if the message was received or not, unless she knows that Bob is going to send an ACK acknowledgement whenever he receives a message. Of course, what you're saying here is that this system that Alice would be sending a message to Bob, if it's somewhat unreliable, then you need to not only Bob needs to receive the message, but he needs to fully process it and perhaps send it to all of the subscribers to his channel before he acknowledges to Alice, okay, I received the message and I passed it on to all of the recipients. Acknowledgement.
Well, I mean, it's more like if we know that Bob actually persisted the message safely and it's going to be able to send it to all of the, subscribers, then it sends the acknowledgement. We don't really require the subscribers to consume the message.
Of course, because the durability is enough of a guarantee that it will make it eventually to all the people that have subscribed.
Yes.
So we're talking about now migrating the queuing system and other elements of this event delivery system. Let's focus on the queuing system. When you're evaluating the queuing system, I think you've already talked about the requirements, but maybe you could reiterate the requirements in a discussion of your options for the new queuing system. What were the different options that you had available at the time, and how did they fit with the requirements of that new queuing system that you wanted to have?
So we actually didn't look at that many options. So we definitely wanted to go with Kafka 0.8 at that time because we were already having Kafka clusters in production, and there were already some teams like the monitoring team which were using Kafka 0.8 in production. So the requirement is that whatever we used as the queuing system or like a Pubsub system, it should not lose any data. And we need to be able to guarantee that. So one of the interesting things that we actually noticed with Kafka is like it did seem to lose data in case like some brokers would actually get restarted, or like they would randomly somehow go out of the cluster, or I don't know. I mean, we didn't really investigate as much. But we also, I think, the last job that actually made us not choose Kafka in the whole of when we were actually considering was the mirror maker. So what this component should have done is like it should have mirrored data event by event or like message by message between two clusters in two different data centers. And it should actually do this reliably in the face of not as reliable network links. But what we actually figured out is the way they actually implemented the mirror maker, it would actually first consume the data from one cluster, send the acknowledgement back to the other cluster, and then try to send it to the destination cluster. And then, of course, like in case you're restarting the mirror makers, in case you're having a network issues, the data gets lost along the way. And I think this was like a big shock, and like I would say one of the biggest reasons why we did not went with Kafka, or why we actually stopped evaluating Kafka.
Talk more about what you ended up evaluating instead of Kafka.
So instead of Kafka, so back in the days, around 2 years ago, we actually, as a company, decided to start moving into a cloud, and as a cloud provider of our choice, it was a Google Cloud. Google Cloud came with a Cloud Pubsub, which at that day, it actually, I don't know, it was actually a scary choice, because at that day, there was no company of our size or even of any size that we knew about that were using it in production. And also it was still in beta. But after actually having done some tests, like the load tests, and also kind of looking if the data gets lost along the way, we decided to proceed with it.
Spotify is a pretty big company. I imagine you have some clout. Were you able to talk to Google about what work they had done with PubSub, whether they were using it internally and had tested it at Spotify scale?
Yes, so we actually have a pretty good relationship with them, and we did meet with the team and we did talk about it. So it did turn out that it is built on top of their internal component, which they've been using for years. How big users they have, of course, I mean, we don't know because that's a confidential thing. But, well, I mean, we were kind of happy with the answer. And I think we were more happy with the tests that we did than the answer that we got, because, of course, you're not really always 100% honest when you're trying to sell something. I mean,
right. What kinds of testing did you do to audit the Cloud Pubsub product?
So it was more like just spinning a lot of publishers and, well, try to publish as much as we can and seeing how is it going to work out. And then there was also a test like trying to spin up as many consumers as we can so we can actually consume the backlog. And also like, well, publishing a certain amount of data and seeing that we're also going to get all the data on the other end. I mean, that test, like to see if the PubSub is losing data or not losing data was like kind of so-so, but as far as we got, I mean, we got insurance that, well, they're not going to lose the data. And we kind of, well, went and trust them on that. And then, of course, like we did prove it with our audit system that we have today on top of our event delivery system.
You have a software project that you want to build. Everybody does. I love building products, but I know more about how software fits together than how to actually write the code itself. I don't spend a lot of time writing code, but I do like to build software. That's why I use Toptal. Toptal is the best place to find reasonably priced, extremely talented software engineers to build your projects from scratch. You can get a pair of Apple Airpods when you use toptal.com/sedaily to work with an engineer for at least 20 hours. And I recommend it. I think it's a great way to build your projects if you don't have time to build them yourself. There's a misconception that engineers have to build all of their own projects just because they're capable of doing that. It's not true. Toptal has only the top 3% of developers. They turn away 97% of the developers that apply to work on the Toptal platform, and that's how you get a matching process that's unlike anything else I have seen in the freelancer marketplace. And I've tried a lot of different freelancing platforms. Toptal has such high-quality engineers, and they listen through the design specifications that you have. They handpick the perfect developer for your project, and this has saved me countless hours in my development process. There's really nothing that compares to Toptal that I have seen. So you can get a free pair of Apple Airpods when you try Toptal at toptal.com/sedaily. Find an engineer that's going to help you build your side project and get your MVP off the ground. As long as you do at least 20 hours, you get those free Apple AirPods. And if you've already got a company that you're working on, you can also use Toptal to scale your team and get everything done faster and raise the bar for your engineering, or get through that blocker that's preventing your company from getting to the next level. So check out toptal.com/sedaily and find an engineer who will help your project succeed. I take it you wouldn't have audited the product as severely if it was something that a ton of people were using. For example, Kubernetes today, you probably wouldn't feel the need to spend a week auditing it for the things that everybody says it's useful for. Or correct me if I'm wrong. Maybe you would audit it with some severe testing.
Yeah, so maybe not as severe, but we would definitely give it a try. I know there is a team using Kubernetes today. And, of course, like when you're using it on a scale and you're actually working with it, you always kind of find some kind of issues which are annoying or not. But it's more like, do you actually have another choice? What would you do if you had another choice? So, for example, in the case of the data scheduling team, which is building their system on top of Kubernetes, seems like the migration at this point, like to go for a mesosphere or something like that, might be too costly, and it actually would not give the benefit they would hope for. So, I don't know.
There were also operational advantages to outsourcing the maintenance of, maintenance may not be the right word, but the uptime, at least, of the Cloud Pubsub system. Certainly, in contrast to, I think, what was the earliest event delivery system, where you were all just managing it all in your own data center. You were managing Kafka. How does that operational advantage manifest? Like, what do you explain how the operational burdens shift from Spotify to Google when you are using a cloud service?
Yeah, so here is an interesting thing. When you're actually using a service, you do not need to take care of your machines. You do not need to recycle the machines that had disk broken, that actually went like crazy for some CPU or something like that. You don't need to upgrade operating system on them. And also you don't really need, in this case, to care about the networking between data centers, which traditionally was not as stable in Spotify. But then again, you kind of trade one evil where you actually, even if it's hard, you actually get complete control, trade it for something else. So for example, sometimes we actually get incidents. So you need to open up a ticket, and then you're hoping that the other side is going to take you seriously and actually start working on it, and they're going to be able to find the problem. But then sometimes if they actually are not able to fix the problem the way you like it, you still need to kind of take some actions and try to figure out how to work around it. Mm-hmm. So I don't know. I would say it's nicer, but it's just a different kind of challenge that we're having now.
Mm-hmm. The migration itself, what was that like? Going from the homegrown Kafka implementation, shifting it to a cloud service like Google Cloud Pubsub?
So I can tell you like this. I mean, we've been a bit special in the whole GCP migration as a team, because we decided not to forklift our stuff and move it into a cloud, but we actually decided to rebuild it. So there were many teams that decided to forklift their services because they were already in a good shape. And that, I would say, that was not as big challenge as you might expect. And I think they didn't really enjoy it as much. But in this case, you kind of get a green canvas or like, I don't know, white canvas. You can do whatever you want. And you actually have opportunity to learn from the mistakes from the previous system and then build something that is going to build work and scale and like be better, or at least you hope it's going to be better, of course. So I would say it was not easy. There was a lot of things that we needed to figure out along the way, but I think it was rewarding at the end.
Okay, so after moving to Cloud Pubsub, how does the event delivery process change? Like maybe you could walk me through the before and after of what is happening when an event gets created and an event gets propagated to a consumer.
So one big thing that we did with the migration is because it was actually a complicated system to rebuild, we decided to keep the API exactly the same. So our consumers and producers didn't see anything. So everything stayed the same, exactly the same for them. But for us, yeah, I mean, unfortunately, the old system is really, really complicated, and I don't think we have enough time, and I actually need my drawings and all that kind of stuff to explain how it did work compared to the new system. So one big thing that we did with the new system is that we wanted to make it as simple as possible. So we would actually be able to understand what component did not work and what failed in the system when the incident comes.
So why don't you talk about the data jobs that run at Spotify? Because that'll get us into a conversation of the other Google Cloud provider technologies that you're leveraging, and I guess I'd like to use that as a way to get into a discussion of cloud providers more broadly. So explain the data. I know that most of the data jobs that run at Spotify, at least at the time of your blog post, were batch, but maybe you could just talk about batch versus streaming and what you're trying to accomplish with your data jobs at Spotify.
So I think most of the data jobs are still batch, and I think that's the meat of the data processing we're doing here, in Spotify. So what we're trying to accomplish, for example, like if you're having a real-time use case that you need to share the updates with the clients as soon as possible, or you want to actually provide like the users with a feedback as soon as possible, or you would actually want to improve the way you're serving the ads, then you would use the stream processing. But in case of the machine learning and actually all the other jobs in Spotify, you would still use batch. The general idea is that basically if you want to have a good quality data, you need to use batch because there are teams which are actually caring about the quality of data. They're cleaning it up. They're also ensuring that everything as it should. And then you would know that once you consume it, it is the correct data that you're consuming.
Mm-hmm. Google has this cloud service called BigQuery, and I know that Spotify was using Hive for its, I guess, large-scale batch data processing. Hive is an abstraction on top of Hadoop. Basically, you can write queries in Hive query language, and which is a high-level kind of SQL-like language, and it executes as Hadoop jobs, which are harder to write. They take more code. How does BigQuery compare to Hive?
So BigQuery was one of the big wins of the migration. So we're having many analysts in Spotify, which are, analyzing the data. And what they like is, they like to do SQL queries. They like to do ad hoc stuff so they could get the results faster. So Hive, the way we are using it, or we have been using it, it was actually just something that we had, but wasn't as maintained as it should. So all the queries that were actually being run on Hive were really, really slow. So when the BigQuery came, these analysts which were using Hive, which just writing the SQL queries, immediately got a boost in productivity, because one query that would actually take in Hive, 10 minutes, 15 minutes, an hour, it would take in order of seconds or a minute into a BigQuery. So I think that was a really big gain for us.
Wow.
But it's also like it's not only that. I mean, the thing is like we're also kind of writing more and more data jobs which are directly using the BigQuery, because sometimes it's simpler to express yourself or like express your logic into a SQL query than actually writing the full-fledged data job.
There's also Google Cloud Dataflow, which I believe you use. Explain what Cloud Dataflow is.
So Cloud Dataflow is a managed service in Google where you can actually submit your jobs that would be written in Apache Beam and they would process the data. And one of the big promises is like you write the job once and then it could be executed in either batch or a stream mode. Well, truth is like it's not more like you write a single job that can do two things. It's more like you know the tool and it's easy for you to write either a batch or a stream job. And on top of Dataflow, one of the things we've built is like it's called Shio. So it's basically Scala wrappings on top of Java, which are actually the way most of the people in Spotify is using Dataflow today.
So, one subject I've tried to understand as I've done these shows is how interoperable different cloud technologies are, or if the benefits are so strong with using a single cloud provider that you kind of want to just use the same technologies, the same cloud provider for different technologies. So here I see you using Google Cloud Pubsub, you're using Google Cloud Dataflow, and you're using Google BigQuery. Is that a coincidence, or are you using it just because there are just really nice, well-defined APIs or integrations with these different technologies?
I would say we're mostly using it because we got a chance and there are nice APIs that we could use. I think we kind of internally did. Well, in the team, we talked like what would happen if we would need to migrate to another cloud provider, and I don't think it would be that easy because you would kind of need to learn yet another API and kind of, change how your system is interacting with this API. And also kind of getting used to all the quirks that each system might have.
Did you consider the AWS stack when you were looking at what PubSub technologies to use and the other cloud provider tools that you wanted to get into? Because I know you were kind of looking at the different clouds and saying, okay, what technologies can we use if we go to Cloud X or Cloud Y? So when you looked at AWS, what made you just go to Google?
So I was actually not part of the discussions. Okay. Or like it's more like there were, I think, I would call it like higher level managers, which were actually the one evaluating why should we go this way and not the other way. In the blog post that our, VP, which, now left, VP of Engineering, he actually said that one of the big reasons why we chose the Google Cloud was based on the big data tools. And the bet was that the Google was in front, many companies, on the big data horizon. There were many open source tools that actually were spawned up or like spin-offs of the Google technology that were built internally. And the bet was like they're probably going to be ahead for at least a few years ahead.
Yeah, totally. It is interesting doing shows with those kinds of companies that are loosely based or tightly based off of Google papers. Like I've done some shows with CockroachDB, which is a database that's based on Google Spanner, and Google has Cloud Spanner also. So it's just interesting hearing the different perspectives on, hey, here is Google's cloud offering that is a productization of this thing that a paper was written about. And then CockroachDB says, we built a product based off of that paper and it has different things. So it's, it's an interesting topic to explore. In this migration, what were the other big data engineering learnings that you had from making this migration?
I think there were actually quite a few of them. So one of the things is like For example, we did try to use Dataflow to consume the events in a reliable way. But well, one of the learning was like, it's not really that easy to do it with the Dataflow because of the nature of reliability and that we must not lose data and that we also need to be operationally responsible for it 24/7. Other thing was like, for example, the way we've been working with Hadoop is not really something that could be just forklifted if you actually start to work with the cloud storage, even if you're actually having a library in between which actually pretends that cloud storage is just like a Hadoop because of the non-atomic folder moves. We also had a, interesting thing that as a part of a migration, we also wanted to go away from scheduling our jobs with cron and actually building a full-fledged scheduler, which is going to give us more feedback where the job is being executed and where is it running, and also seeing the log data for it.
Machine learning is so core to what Spotify does and how the product advances in quality. How much time do you spend with machine learning teams, and how does the preponderance of machine learning within Spotify, how does that affect data engineering decisions?
The sad part, I mean, I would like personally to spend more time with them, but unfortunately that's not the truth, because my team and some of the other data infrastructure teams are actually based in Stockholm, while the core of the machine learning is based in New York. So there is not that much mingling between us to actually see how the stuff are going. Yeah, but I mean, we do talk a lot of machine learning, and right now there is a lot of focus on, for example, making machine learning as easy as possible. We also have this data university where we want to make data accessible to many engineers that are not data engineers in Spotify, so we could actually have them change their role and go and try to do something with the machine learning a bit.
Cool. Okay, well, to wrap up, maybe you could talk about the initiatives that are going on within the data engineering team right now, or perhaps how the event delivery system is evolving.
So right now, I mean, the big thing that we've been working on is making sending events as easy as possible. So right now we have some library, and it's pretty complicated to send events. And we want to empower many of our engineers to be able to send as many events as they could, so we could actually be able to learn what our users want and need as fast as possible. The other big thing that we have as a data engineering is also right now the whole Google Cloud migration. So there is a large percentage of data jobs which are still being executed on a Hadoop cluster, and we want them to be moved into a cloud. So this could be either they would forklift them and run them on a managed Hadoop clusters in Google Cloud, or they would just rewrite them by using Dataflow. I think that's the two. The migration path is the biggest thing that's been happening in data engineering right now in Spotify.
All right. Well, Igor, I want to thank you for coming on Software Engineering Daily. It's been great getting an inside look at the event delivery system, and I really appreciate your work because I use Spotify on a daily basis. It's a product that is, a core component of my day-to-day life.
Thank you, Jeff. Thank you, for having me, and I'm really glad to hear that you like Spotify and you've been using it.
If you want to start a podcast, check out Podsheets.
Podsheets is a product we built to create and manage podcasts. We are podcasters ourselves, and we understand the difficulties of getting started.
You have thought about starting a podcast, but there are so many questions.
Is it expensive to get audio equipment?
No, it's not. You can get a decent mic for $20, or you can get started with just an iPhone headset.
Is it hard to get a good quality audio recording?
It's actually easy. We will show you how to record your audio and get good fidelity.
Okay, how do you edit an episode?
We will teach you how to edit an episode, or to help you find an editor who will edit your episode for $5 or $10 per episode.
And then how do I post my episodes? How do other people get access to them?
Podsheets makes it easy to post your episodes and distribute them to iTunes and Google Play with a single click.
If you're curious about podcasting but have no idea where to start, Podsheets will guide you through the process.
Podsheets is built by podcasters for podcasters. With Software Engineering Daily, we've been producing 5 shows a week for 2 years. We understand recording, we understand how to produce your show, and we understand how to get advertisers. We want to help you with this process.
Check out Podsheets today. We will give you everything you need to create and manage your podcast. And if you have any questions or get confused, you can always contact us directly for help. Podcasting is as easy as blogging. Let us show you how to podcast with Podsheets.
Wow!